Natural language processing is a fascinating field that has revolutionized the way we interact with computers and machines. From virtual assistants like Siri and Alexa to language translation apps and sentiment analysis tools, NLP has become an integral part of our daily lives. However, getting started with NLP can seem daunting, especially for the beginners who are new to programming and machine learning. That's why we have put together this collection of simple yet powerful Python codes for hands-on projects in NLP. So whether you are a student, a developer, or simply a curious learner, these codes will help you get started with building your own NLP applications, from text classification and sentiment analysis to language modeling and text generation. With these codes, you will be able to dive into the world of NLP and start building your own projects in no time without getting bogged down in complex theory or tedious implementation details. So let's get started and explore the exciting world of NLP together. First, the basic introduction about NLP, which is a subfield of artificial intelligence that deals with the interaction between the computers and humans in natural language. It involves the use of algorithms and statistical models to process, analyze, and generate natural language. Python is a popular programming language used extensively in NLP because of its simplicity, flexibility, and extensive libraries. And the most common used libraries in NLP are Natural Language Toolkit, which is a comprehensive library for NLP tasks such as tokenization, stemming, and corpora management. spaCy is a modern library for NLP that focuses on performance and ease of use with features such as tokenization, entity recognition, and language modeling. TensorFlow and PyTorch are popular deep learning libraries used for building and training NLP models. Next comes the simplest Python codes for hands-on projects in NLP applications. Covers a range of tasks which includes classifying text into predefined categories such as spam versus non-spam emails, determining the sentiment or emotional tone of text such as positive, negative, or neutral, predicting the next word in a sequence of text given the context of the previous words, generating new text based on the given prompt or context, and finally identifying and categorizing named entities in text such as people, organization, and location. Next comes the theoretical concepts. Well, the simplest Python codes for hands-on projects rely on various theoretical concepts, which includes tokenization or breaking down text into individual words or tokens. Stemming and lemmatization include reducing words to their base form to reduce dimensionality. Vector space models means representing text as vectors in a high-dimensional space to enable mathematical operations. Machine learning enables using algorithms such as supervised and unsupervised learning to train models on labeled and unlabeled data. Deep learning involves using neural networks to learn complex patterns in text data. So by understanding these theoretical concepts and using the simplest Python codes for hands-on projects, developers can build a range of NLP applications from chatbots and language translation to sentiment analysis and text classification tools. For better understanding, let's understand it using the Python codes. So let's get started with Python coding. So these are the projects. In the first project, we'll discuss about the text classification. So we are starting this project by importing the Natural Language Toolkit library, which is a comprehensive library used for natural language processing tasks. After this, we will download the Punchet tokenizer model for tokenizing text. Then we will import the word tokenize function from the NLTK library, which is used to tokenize text into individual words. After this, we import the TF-IDF vectorizer class from scikit-learn library, which is used to convert text data into numerical representation using term frequency inverse document frequency technique. After this, we import the train test split function from scikit-learn library, which is used to split the data into training and testing set. Then we import the multinomial NB class from the scikit-learn library, which is used to implement a naive-based classifier for multi-class classification. After this, we need to load the data set. So here we are defining a list of two test samples, one positive, one negative, which can be used as the training data. Also, we are defining a list of labels corresponding to the text samples, where 1 represents the positive review and 0 represents a negative review. After this, we will download the Punchet tokenizer model for tokenizing text, and this line is unnecessary because we have already done that. Okay, after this, we will tokenize each text sample in the train data list using word tokenize function and store the results in a new list called tokenize train data. Then we will create a TF-IDF vectorizer. So we have created an instance of TF-IDF vectorizer class, which can be used to convert the text data into numerical representation. Then we fit the TF-IDF vectorizer instance to the trained data list and transform the text data into numerical representation. Here the resulting matrix is stored in xtrain variable. Then we split the data into training and the testing data sets. So here we have split the xtrain matrix and the train label list into training and testing sets using train test split function. The test size parameter is set to 0.2, which means that 20% of the data will be used for testing and the rest will be used for training. The random state parameter is set to 42, which ensures that split is reproducible. Then we will start training the naive Bayes classifier. So here we have created an instance of multinomial naive Bayes classifier class, which will be used to implement the naive Bayes classifier for multi-class classification. Next, the clf.fit line will fit the naive Bayes classifier to the training data using fit method. And then we will start making predictions on the test data set. Then we will evaluate the model of the naive Bayes classifier using score method, which returns the accuracy of the model in the test data, and the result is printed to the console. So after running this code in Google Colab, we'll get the accuracy 0. Why so? Because we have just taken two training data. This is positive review, this is negative review. We need to add more training data and then train labels, and then the accuracy will keep on increasing. The second project is related to sentiment analysis. Here also we are starting by importing the natural language toolkit library, which is a comprehensive library used for natural language processing task. Then we will download the WADR, that is Vellens Aware Dictionary and Sentiment Reasoner Lexicon, which is a pre-trained sentiment analysis model. So this WADR lexicon is a popularly widely used sentiment analysis tool. Then we will import the sentiment intensity analyzer class from the NLTK library, which is used to analyze the sentiment of text data. After this, we will define a text sample that will be used to analyze the sentiment. Then we will initialize the WADR sentiment analyzer. So first of all, we'll create an instance of sentiment intensity analyzer class, which is used to analyze the sentiment of text data. Here the sentiment intensity analyzer class uses the WADR lexicon to analyze the sentiment of text. Then this analyzing sentiment. So here the sentiment line will use the polarity scores method of the sentiment intensity analyzer class to analyze the sentiment of text data. The polarity scores method returns a dictionary with 4 sentiment scores. Pos means the proportion of the text that falls into positive sentiment category. Neg means the proportion of the text that falls into negative sentiment category. Neutral means that falls in neutral sentiment category. And compound is the compound score that calculates the sum of all the lexicon ratings, which has been normalized between -1, that is most extreme negative, and +1 means most positive. Then we will print the sentiment scores, and finally whether it's positive, negative, so we'll print the all scores here. And the output of the code will be a sentiment score for the text data, which will be used to determine the overall sentiments. So after running this code in Google Colab, we are getting the results like this, where we are getting, as we have taken I love this product, so here positive sentiment value is high and the compound sentiment is high. Next, the third project is named entity recognition. Now here also we are starting by importing the spaCy library, which is a modern natural language processing library for Python. spaCy is known for its high performance streamlined processing of text data. Then we will start loading the data. So here we will define a text sample that will be used to demonstrate the name entity recognition capabilities of spaCy. Then we'll load this spaCy model. So here we are loading a pre-trained spaCy model for English language processing. NCore Web SM model is a small English language model which is suitable for most NLP tasks. Here the model is loaded into the NLP variable, which is an instance of the language class. Then we'll start processing the text. So first of all, we'll process the text sample using NLP model. NLP model tokenizes the text, performs part of speech tagging, name entity recognition and dependency parsing, and the resulting processed text is stored in doc variable, which is an instance of the doc class. Then we'll start extracting the name entities. So here it will first extract the name entities from the processed text. Then doc.ends attribute is an integrator over the name entities in the text. The list comprehensions iterates over the name entities and extract the text and label of each entity, and the resulting list of tuples is stored in entities variable. Then it shall start printing the entities. So here after running this code in Google Colab, we are getting the results like this, where the text was Apple is a technology company based in California, and the result is Apple is organization, California is the geographical location. So here the spaCy model has used a variety of techniques like tokenization, where it has broken down the text into individual words. Part of speech tagging means identifying the part of speech such as noun, verb, adjective. Then it has used name entity recognition, whereas it has identified the name entity such as organization or geographical locations. So ENCODE Web SM model is a pre-trained model that has been trained on a large corpus of text data. Next, fourth project is language modeling. So here we'll start this project by importing the libraries like Torch, which imports the PyTorch library, which is a popular deep learning framework. Then it will import the PyTorch neural network module, which provides various neural network layers and functions. Then it will import the PyTorch optimization module, which provides various optimization algorithms for training neural data. Then we'll start loading the data set. So it will define a text sample that will be used to train the language model. Then it will tokenize the text into individual words or tokens. Then it will create vocabulary mapping. So here we are creating a vocabulary mapping that maps each token to the unique index. So this set tokens impression removes duplicates from the list of tokens, and enumerate function returns a tuple containing the index and the value of each token. Next, this index token line will map each token to its corresponding index using the vocabulary mapping. Then we will create a language model here. So here in this creating language model, we will define a custom neural network class called language model that inherits from the PyTorch nn.module class. And then we will define the constructor method of the language model class, which initiates the model's parameters. After this, we will define an embedding layer that maps each token to the dense vector representation. Then we will define a recurrent neural network that processes the embedding token representation. After this, that self.fc line, so which is defining a fully connected layer that generates the output probabilities. Then we will define the forward pass method of language model class, which defines how the input data flows through the model. Then we will embed the input tokens using the embedded layers. Then we will process the embedded token representations using the RNN layer. Then we generate the output probabilities using fully connected layer. After this, we will initialize the model and optimizer. So here we are initializing an instance of the language model class with a vocabulary size of an embedding dimension of 128 and hidden dimension of 128. Then we define the loss function, which is used to train the model, which is a cross entropy loss. And then we define an optimization algorithm used to train the model, which is Adam with a learning rate of 0.001. Then we will start training the model. So here we define the loop that trains the model for 10 epochs. Then it zeros the gradients of the model's parameter, and then it passes the index token as input to the model and generates the output probabilities. Then it calculates the loss between the output probabilities and target token. Then it computes the gradient of the loss with respect to model's parameter. Now here optimizer.step line will update the model's parameter using gradients and optimization algorithm, and finally it prints the epoch number and loss value at each epoch. And this is very simple example of the language model, and there are many ways to improve it, such as adding more advanced architectures, pre-training on large corpus, and fine-tuning on specific tasks. So after running this code in Google Colab, we are getting the loss for each epoch. Next comes the fifth project, which is used for text generation. So here also we'll start this code by importing the libraries like Torch, which is a PyTorch library. Then we will import the PyTorch neural network module, which provides various neural network layers and functions. Then we will import the PyTorch optimization module, which provides various optimization algorithms for training neural network. Then we will load the data set. We will tokenize the text into individual words or tokens. Then we will create the vocabulary mapping. That is, we will create a vocabulary mapping that maps each unique token to unique index. Then we create a reverse vocabulary mapping that maps each index to its corresponding token here. The word to index, then index to word. Then we will create a text generator. So here we are creating a custom neural network class called text generator that inherits from the PyTorch nn.module class. Then we will define the constructor method of text generator class, which initializes the model's parameter. Then this self.embedding layer will define an embedding layer that maps each token to a dense vector representation. Self.rnn line will define a recurrent neural network layer that processes the embedded token representation. Self.fc line will define a fully connected layer that generates the output probabilities. After this, we will define the forward pass method of text generator class, which defines how the input data flows through the model. Then we will embed the input tokens using embedding layers. And then this output line will process the embedded token representation using RNN layer, and it will generate the output probabilities using fully connected layer. Then we will start initializing model and optimizer. So here we will define the vocabulary size, which is the number of unique tokens in the text data. Then we initialize an instance of text generator class with a vocabulary size of vocab size, an embedding dimension of 128 and hidden dimension of 128. Then we define the loss function used to train the model, which is cross entropy loss. Then we define the optimization algorithm used to train the model, which is ADAM with a learning rate of 0.001. And then we will start training the model. So here we will first define a loop that trains the model for 10 epochs. Then we zeros the gradients of model's parameter. Then we convert the tokens to numerical indices before feeding them to the model. Then we pass the input indices to the model and generate the output probabilities. Then we define the target index, which is the index of last token. Then we calculate the loss between output probabilities and target index. Then we compute the gradient of loss with respect to model's parameter. Now here optimizer.stepline will update the model's parameter using the gradients and optimization algorithm, and then it will print the epoch and the loss value at each epoch. Then this generating text line will define a function that generates text using trained model. So here it will get the index of start token. Then it will initialize a list to store the generated token indices. Then it will create a loop that generates token up to the maximum length. Then it passes the current token indices to the model and generate the output probabilities. Then it gets the indices of token with the highest probability. Next, this token indices.append will append the generated token index to the list. Then this generated token line will convert the generated token indices back to words, and then it will return the generated text. And finally, it will generate text using trained model and print the results. So after running this code in Google Colab, we are getting the loss for each epoch, and finally we are getting the generated text here. Here the generated text is not accurate much because we have given the dummy data of one line, but it can be improved by adding more data sets. And that's the wrap. Developing NLP applications can be a fun and rewarding experience, and with the right tools and resources, anyone can get started. The Python code shared in this video provides a solid foundation for building a wide range of NLP applications, from text classification and sentiment analysis to language modeling and text generation. By working through these codes and experimenting with different techniques and tools, you will gain hands-on experience with NLP and develop a deeper understanding of the underlying concepts and principles. So whether you are a beginner or an experienced developer, we hope that this video has inspired you to explore the exciting world of NLP and start building your own projects. Remember, the key to success in NLP is to keep practicing, experimenting and learning, and with persistence and dedication, you can unlock the full potential of NLP and create innovative applications that can make a real difference in people's life. So keep coding and happy NLPing. Thank you.